Scene script. Have you ever wondered why earthquakes occur? These natural phenomena are a source of intrigue and quite often fear. Earthquakes shake the very ground beneath us, causing destruction and chaos, and yet they're an integral part of the Earth's dynamic nature. Many people have preconceived notions about earthquakes. Some believe they're caused by the wrath of the gods, while others think they're the result of some cosmic event. But these are just myths, stories spun by our ancestors to explain the unexplainable. Understanding earthquakes is crucial because it helps us better prepare for them, potentially saving lives and reducing destruction. It's a fascinating subject intertwined with geology, physics, and even history. The truth about earthquakes is much more grounded in science than myth. They're not random events, but are caused by specific, understandable processes that occur deep within our planet. So, what really causes an earthquake? Stay tuned to find out. To understand earthquakes, you first need to know about the structure of the Earth. Imagine peeling an orange. You'll see that it is composed of several layers. The Earth, too, has layers, and each one plays a crucial role in the occurrence of earthquakes. The outermost layer, much like the skin of the orange, is called the crust. The Earth's crust is a thin, brittle shell that covers the entire planet. It may seem insignificant, but it's where all the action happens. The crust is where we live, where mountains rise, and where earthquakes occur. Beneath the crust, we find the mantle. This layer is much thicker, making up about 85% of the Earth's volume. It's not solid rock, but rather a super-hot, semi-fluid substance that flows very, very slowly. Think of it like a pot of thick stew on a slow boil. Movements in the mantle can cause the crust to crack and shift, leading to earthquakes. Finally, at the heart of the Earth lies the core. It's divided into two parts, the outer core, which is liquid, and the inner core, which is solid. The core is incredibly hot, hotter than the surface of the sun. The heat from the core drives convection currents in the mantle, which in turn move the crust. Now, how does this all relate to earthquakes? Well, the Earth's crust isn't one solid piece. It's broken up into several large pieces, known as tectonic plates. These plates float on the semi-fluid mantle, and their movements can cause the ground to shake, leading to earthquakes. So in essence, earthquakes are the result of the dynamic nature of our planet. They occur when the Earth's crust, driven by the heat and movement of the mantle and core, shifts and cracks. Now that you're familiar with the Earth's structure, we can delve deeper into the actual cause of earthquakes. The Earth's crust and upper mantle are broken into large pieces known as tectonic plates. These massive sheets of rock, some spanning thousands of miles across, are not static. Instead, they're constantly on the move, albeit at a pace slower than a snail's crawl. In fact, tectonic plates are continuously interacting with each other, creating a dynamic and ever-changing landscape on Earth's surface. Picture a giant global game of puzzle pieces, each one sliding, colliding, and pulling away from the others. This, in essence, is the dance of the tectonic plates. The Earth's crust is divided into several of these pieces. The largest ones include the Pacific Plate under the Pacific Ocean, the North American Plate, and the Eurasian Plate. But there are many smaller ones too, each with its unique path and behavior. Now let's talk about how these plates move. They don't just wander randomly. Their movements are driven by intense heat deep within the Earth's core, causing convection currents in the mantle, the layer just below the crust. These currents push and pull the plates in different directions. These movements lead to the formation of three types of plate boundaries: convergent, divergent, and transform. Convergent boundaries form when two plates collide or converge, often giving rise to mountain ranges or deep ocean trenches. Divergent boundaries occur when two plates move or diverge away from each other, creating a gap where new crust can form, like at the Mid-Atlantic Ridge. Lastly, transform boundaries are where two plates slide past each other, like the infamous San Andreas Fault in California. Each type of movement creates different geologic features and can trigger various seismic activities. So, when we feel the ground shaking beneath our feet, we're actually experiencing the Earth's tectonic plates at work. The interaction between these tectonic plates is the main cause of earthquakes. Their constant movement, the energy it generates, and the resulting shifts in the Earth's crust are all part of the complex and fascinating process that leads to earthquakes. Now, let's get to the heart of the matter. How do these tectonic plates cause earthquakes? Imagine holding a rubber band between your fingers, stretching it tighter and tighter. This is akin to the stress that builds up along the fault lines, the boundaries where tectonic plates meet. Over time, as these plates move past each other, they can get stuck due to friction, and stress begins to accumulate. Just like the rubber band that's being stretched, the Earth's crust is also being pulled and pushed, storing up energy. But what happens when you stretch a rubber band too far? It snaps, doesn't it? And when it does, it releases all the energy that was stored up during the stretching. That's exactly what happens during an earthquake. When the stress on the Earth's crust becomes too great, it gives way, causing the rocks to break and the tectonic plates to move suddenly. This sudden movement releases the pent-up energy, which is then radiated outwards in the form of seismic waves. These seismic waves are the culprits behind the shaking and trembling we experience during an earthquake. They travel through the Earth's crust, causing it to vibrate, much like how ripples spread out when you toss a stone into a pond. These vibrations are what we feel as the ground shaking beneath our feet. So that's the science behind earthquakes. In the past few minutes, you've learned a lot about earthquakes. We dived into the Earth's structure, exploring its various layers. We discussed the tectonic plates that make up the Earth's crust and lithosphere, and how their movements cause the ground to tremble beneath our feet. These tremors are what we experience as earthquakes. Remember, understanding earthquakes is not just about satisfying our curiosity, but also about making our world a safer place. Thanks for watching.